Before we get too far into this, let's go over some things you might need to know before doing stoichiometry. First, you need to know how to write basic chemical reactions. Second, how to name binary compounds, so transferring from its symbols to the actual written out name of a compound. Third, how to balance equations, making sure there are equal amounts of components on either side of the arrow. And fourth, molar conversions. I'm going to go over these in the video, so you don't have to go too in depth, just keep these in mind. On to the work. We have 5 main steps that we take when doing stoichiometry. First, we write out the equation according to the information given to us in the problem. Second, balance. Third, convert whatever unit you have to moles, since moles are the standard unit of measurement across all elements, since every element has its own number of protons, neutrons, and electrons. Fourth, we use a mole ratio to convert between moles of different substances. And finally, we convert moles to the final unit of measurement, which is usually grams of a certain substance. You're going to need a basic calculator, a periodic table, or a chart that includes the molar mass of all your elements. Finally, a snack. This isn't required, I just really like food, okay? Let's move on. So let's get started on our first example. Our first question is how many moles of aluminum oxide will be formed from 17 moles of aluminum? If you look at our question here, the first 3 steps have already been done for you. The equation's written out, it's balanced, and our first question is 17 moles of aluminum, so it's been converted to moles already. So our next step, step 4, is to use a mole ratio to convert between moles of aluminum and moles of aluminum oxide. We see here that our ratio is 4 to 2. We set this up as an algebraic fraction problem. We cross multiply, and we come up with the answer of 8.5 moles of aluminum oxide. That's the answer to our question here. Part B. How many grams of oxygen are needed to burn 42 grams of aluminum? We're given grams of aluminum. Our first 2 steps are already done. So our third step is to convert grams of aluminum to moles of aluminum so we can compare the two equally. Here we have our ratio of moles of aluminum to grams of aluminum. We got 26.98 grams from the periodic table. This is the molar mass. So we multiply this by the information given here, 42 grams of aluminum. We come up with the answer of 1.6 moles of aluminum. Our next step on our list is to use a mole ratio to convert between moles of aluminum and moles of oxygen. Our ratio shown here is 4 moles of aluminum to 3 moles of oxygen. So we multiply this by our 1.6 here, set it up as an algebraic problem, cross multiply, and we come up with the answer of 1.2 moles of aluminum. Our next step is to convert to our final unit of measurement, which is grams of oxygen. So we have our ratio down at the bottom here that is 16 grams of oxygen to 1 mole of oxygen. Once again, we got this information from the periodic table, the molar mass. So we take 1.2 moles of oxygen, do the simple math, and we come up with 19.2 grams of oxygen needed. And that's our answer. Example 1 was fairly easy because we got to skip a couple of steps, but here we're going to have example 2, which is going to get a little tougher. Iron oxiders reacted with aluminum to form aluminum oxide and iron. A. Write and balance the equation. B. If you have 3 moles of iron oxide, how many grams of aluminum is produced? And C. If you have 60 grams of aluminum, how many grams of iron oxide do you need? So we go to step 1 on our list, which is to write the equation. I'm going to let you pause the video for a second so you can do this on your own, and I'll explain. The answer is shown here. Because we know that oxygen always forms a negative charge, a charge of -2, and we need 3 of those to make a charge of -6 so that we can have iron with a charge of +3 to balance out the equation. Then there's plain aluminum. Then next we have aluminum oxide. Since aluminum has a charge of +3 and oxygen has a charge of -2, we simply switch the two numbers and come up with the answer Al2O3, and then we have plain iron there. Our next step is to balance the equation. So once again, I'm going to have you pause the video real quickly so you can go over this with yourself. The answer is shown here. This was fairly easy to balance the equation. We just had to make sure that there were equal parts of everything on both sides. Our next step is to convert to moles. Here we are given 3 moles of iron oxide. So this step is done for us already. I just copied the equation there so we can remember it. So our next step is to convert a mole ratio. Here we're shown that the ratio of aluminum oxide to iron oxide is 1:1. So 3 moles. So if we have 3 moles of iron oxide, we're going to have 3 moles of aluminum oxide. Our next step is to convert to grams. So we're given our ratio of moles to grams here. This is where we have to do a little bit of calculator math. We're shown here we have 2 atoms of aluminum. If we go to our periodic table, we see that the molar mass of aluminum is 26.98 grams. Since we have 2 atoms of aluminum, we multiply that by 2 and get the answer 53.96. Now we have to solve for the oxygen component. So since oxygen has a molar mass of 16 and we have 3 atoms of oxygen, 3 times 16 is 32 grams per mole. Add that together and we have a total of 85.96 grams per mole of aluminum oxide. We have our conversion right there. So next we multiply our 3 moles of aluminum oxide. And we get an answer of 257.88 grams. That's our answer to part B. All right, let's go on to C. If you have 60 grams of aluminum, how many grams of iron oxide do you need? It gives us grams, so what do we have to do? That's right, we have to go to step 3 and convert the grams of aluminum to moles of aluminum so it's standardized. Here we have a molar mass of 26.98 grams of aluminum. Multiply across the top and divide by the bottom, and we get 2.2 moles of aluminum. Step 4 is to use a mole ratio to convert from moles of aluminum to moles of iron oxide. Shown here, we have a ratio of 2 moles of aluminum to 1 mole of iron oxide. If we multiply 2.2 moles of aluminum across the top and divide by the bottom, we get a total of 1.1 moles of iron oxide. That completes step 4. So now we move on to our final step, converting to the final unit of measurement, which is going to be grams of iron oxide. We need to find our molar mass of iron oxide, so we refer back to our periodic table. If we have 2 atoms of iron and the molar mass of iron is 55.85, we get an answer of 111.7 grams per mole. If we have 3 atoms of oxygen and its molar mass is 16 grams, we do the math and we get 48 grams per mole. Add it up, and our total molar mass for iron oxide is 159.7 grams per mole, and we move that here. Do the math, multiply across the top, divide by the bottom, and our answer is 175.67 grams of iron oxide. Of course, these examples that I showed you today aren't the only ways that stoichiometry can be used. Of course, many equations have polyatomic ions or different kinds of elements in them. But as long as you remember these 5 main steps, you'll have a much easier time solving stoichiometry. And I know seeing all the numbers and symbols on the page is really, really daunting sometimes, but trust me, as long as you keep in mind that it's just a matter of ratios and simple conversions, you'll do great. So good luck with your chemistry homework and see you next time.